Hello everyone, today let's solve this calculus related rates problem together. So in this scenario, we have a person who stands 30 feet away from point P and he watches a balloon rise vertically from the point. So if we name the distance between the person and the balloon to be x and the distance between the P and the balloon to be h, we can start figuring out relationships. We see that the balloon is rising at a constant rate of 2 feet per second, and this means that the height of the balloon is increasing by 2 feet per second. So we know that the rate of change of h with respect to t is equal to 2 feet per second. We also notice that the distance between the person and P does not change, so the rate of change of x with respect to t is 0 feet per second because it's a constant. The question wants us to find the rate of change in radians per second of the angle theta. So we can use our trig rules and represent theta as opposite over adjacent, so h over x. And we want to find it at the instance when the balloon is 40 feet above point P. So when we have this specific situation, we can construct another diagram. X is equal to 30, and over here, h is equal to 40 because it's 40 feet above point P. dh over dt is still 2 feet per second because the balloon is rising upwards. Dx over dt is still 0 feet per second. And tan of theta is now h over x as usual. So there are actually two ways to solve this problem. For the first type, we can express theta as its own function of h and x and then differentiate it with respect to t, or we can use implicit differentiation and differentiate both sides. So both sides work. Let's try them out one by one. Method 1. So for the first method, let's write theta as its own function. So we can write theta is equal to arctan times h over x. If you recall your inverse derivative rules, arctan of u is equal to, the derivative of arctan of u is equal to 1 over 1 plus u squared minus u prime. So over here, d theta over dt is equal to 1 over 1 plus h over x squared minus the derivative of h over x. And x is a constant, so we can pull it out. 1 plus 1 over x squared times h over x squared times 1 over x times dh dt. And we know that dh dt is 2, so it's actually 1 over 1 plus h over x squared times 2 over x. In the particular situation where h is equal to 40 and x is equal to 30, we can sub it in, so d theta over dt is equal to 1 over 1 plus 40 over 3 is just 4 over 3 squared times 2 over 3 times 2 over 30. So we have 1 over 1 plus 16 over 9 times 1 over 15. 1 plus 9. 1 over 15, this is 3 over 75, 25 times 5 is equal to 125, 3 over 125, which is B. But let's try out the second method, which is implicit differentiation. So once again, we have tan theta is equal to h over x. Now in this case, we just differentiate both sides without expressing one as a function of another. So the derivative of tangent to theta, tangent theta is equal to secant squared theta times d theta over dt. And over here, 1 over x is a constant, so times dh over dt. So once again, we construct our triangle, not drawn to scale. Let's change it to V2 scale. 30, 40, 50. So if we move secant squared, this is 1 over cosine squared, so we will have cosine squared times 1 over x times dh over dt, and cosine theta is just 3 over 5, so we will have 30 over 50, so 3 over 5 squared times 1 over x is 30, 1 over 30, dh dt is 2, so we have 9 over 15, 9 over 25 times 1 over 15, again cancel out 3, 5, so 3 over 125. So in conclusion, the answer to this related rates problem is B over, which is 3 over 125.